Okay, so these are questions 9, 10, 11 on chapter 3, all dealing with empirical formulas. First one says phosphorus spontaneously bursts into flames in oxygen if 6.5 grams of phosphorus reacts with oxygen to form 11.54 grams of phosphorus oxide. What is the empirical formula of this oxide? Now, two things right away. They give us 6.5 grams of phosphorus. Okay. And they also give us 11.54 grams of phosphorus oxide. Now, to find the empirical formula, we just want oxide, or the oxygen, sorry. So how do we find the mass of just oxygen? Well, the conservation of mass, law of conservation of mass, says the mass cannot be created or destroyed, matter cannot be created or destroyed. So if we end up with 11.54 grams of phosphorus oxide, and we put in 6.5 grams of phosphorus, then that means that the rest of the weight, or the difference in the weight, basically 11.54 minus 6.5, is going to give us the mass of our oxygen. So if you do 11.54 minus 6.5, you should get 5.04 grams of oxygen. Okay, so right now we are in grams. To find empirical formulas, we need to go to moles. All right, so just like we've been doing up to now, 6.5 grams times 1 mole of phosphorus over 30.974. Okay, 1 mole of phosphorus is 30 grams, sorry, 30.974 grams of phosphorus. We can cancel this out. Okay, and now what we can do is have the moles of phosphorus at this point. So now 6.5 over 30.974, 30.974 is going to give us our moles of phosphorus. So this will equal 0.2 moles of phosphorus. Over here, same thing, we need the moles of oxygen. So oxygen is 15.999. 1 mole of oxygen is going to be 15.999 grams of oxygen. We cancel this out right here, grams of oxygen over grams of oxygen. So if you go ahead and put in 5.04 divided by 15.999, you should get 0.3 moles of oxygen. Okay, so 0.2 and 0.3 are the simplified numbers that you get from those from this process. If you do 6.5 grams over 30.974, you actually get 0.20985. But that's too big. You want to keep it simple. Just put 0.2. For 5.04 over 15.999, you get something like 0.315. Again, that's too big. We can just keep it simple. 0.3 is good enough. Now, every time you see empirical formula or limiting reagent, we're going to see this later on a little bit. Limiting reagent, you're going to divide by the lowest number of moles. For example, in this question, 0.2 is lower than 0.3. So if we do 0.2 divided by 0.2, 0.3 divided by 0.2. We're going to get the ratios of moles between phosphorus and oxygen. So 0.2 over 0.2 just gives us 1 mole of phosphorus. And then 0.3 moles of oxygen over 0.2, that's going to give us 3 over 2. 3 over 2 moles of oxygen. So that means that for every mole of phosphorus, we're going to have 3 over 2 moles of oxygen, or 1.5. Same thing. Now, we can have a little starting empirical formula, P1. So for every phosphorus, you've got 3 over 2 oxygen. Now, the problem here is we can't have fractions in our subscripts. So we're going to multiply by a number so that this 3 over 2 cancels out and we get a whole number. In this case, 3 over 2, if we multiply by 2, equals 3, because these 2 and 2 would cancel out. So I'm going to choose 2 for this one. It's not always going to be over 2. It might depend. So just make sure you multiply by the right number so you get the right empirical formula. So in this case, 2 times 1, the 1 being the phosphorus, is 2. So P2. And then 3 over 2, remember 3 over 2 times 2 is just 3. So O3. P2O3 would be our empirical formula for number 9. Okay. Number 10. Combustion of 0.5 grams sample of hydrocarbon yielded 0.973 grams CO2 and 0.319 grams H2O. What is the empirical formula of the hydrocarbon? Now, a hydrocarbon, hydro is in there, hydrogen is H, and carbon is in there. That's a C. So we're trying to find the subscripts for these C and H. But the good thing is, they gave us the grams of CO2 and the grams of H2O. But I just said you only need C and H. CO2 has that extra oxygen. H2O has that extra oxygen. So what are we doing here? We need to find the ratio of CO2, carbon dioxide, to carbon, and the ratio of H2O to hydrogen. So let's do, for example, CO2. Let's try that out first. 0.973 grams of CO2 over 1. So I'm going to show you the process for CO2, and I want you guys to try out the process for hydrogen. Don't worry, I'm still going to work both of them out, but I just want you to pause the video after I finish CO2 so you can try H2O on your own. Enough said. 0.973 grams of CO2. I need to turn this into moles, and this is going to be the same process for you to turn it into hydrogen into moles. So they give us the grams. I need to find the weight of CO2 because we got 1 mole CO2 over the grams of CO2. So we've got carbon, which is 12.011, and we've got oxygen, which is 15.99. But don't forget, there's 2 oxygens. So we got to do 15.999 times 2, which gives us 31.999. Oh my god, hold on. 31.998 plus our carbon, which is 12.011, and gives us 44.009. And there we go. Now we got grams canceled out, and we end up with moles of CO2. So let's just go ahead and find 0.973 divided by 44.009. That gives us 0.022. 0.022. Right? Okay, let's keep it simple. No more than that. Moles of CO2. Okay. Now, here, remember we just want carbon by itself. So for every carbon, okay, we don't need the weight right now, but for every carbon in CO2, there is one CO2. For example, let me just show you, right? 1 mole of CO2 carries only 1 mole of carbon, right? So whenever you get to this point, for example, for hydrogen, you got to be careful, because for every mole of H2O, how many moles of hydrogen do you have? Well, look at the subscripts. There's 2. So instead of being 1 to 1, like this ratio right here, this ratio would be 2 mole of hydrogen, because there's, oh, come on, there we go, 2 moles of hydrogen, because there's 2 H in water. There's 2 hydrogens in water. Okay, so after you do the top part, back to the top part, 0.022 times 1 over 1, well, that's the same thing. That would equal 0.022 carbon, or moles of carbon. All right, so go ahead, pause this video, try to do this process, but of course you're finding 0.319 grams of H2O. All right. Pause video, go ahead. All right, I don't actually have to give you time, you can just pause the video. So hopefully you already paused it. You already worked it out. So your first step should have been to find the mass of H2O. So we got 1.008 times 2. Don't forget, we got 2 hydrogens. 1.008 times 2 plus our oxygen, which is 15.999. Okay. Okay. Should give us 18.015 grams of H2O for every mole H2O. Okay, so now we got 3.319 over 18. 0.015, sorry. So 0.319 divided by 18.015. There we go. You can see here, your calculator should give you 0.017. 0.0, hold on. Okay, 0.178, because the number is actually 0.0177, right? But we want to keep it simple. We'll do a little rounding right there. So 0.018. Now, this is mole of H2O. Hopefully, we're all good up to this point. So 0.018 mole of H2O for every mole of H2O, we've got 2 moles of hydrogen. So remember, this time we're going to multiply 0.018 times 2. And this should give us 0.036 moles of hydrogen. Okay, now remember the step that I told you guys that is necessary for empirical formulas is dividing by the lowest number of moles. So here we got 0.022 and 0.036. The lowest one would be 0.022. Let's go ahead and do that one right there. 0.022. Both of these get the treatment, 0.022. So this 0.022 over 0.022 would be 1 carbon. And then 0.036 over 0.022 would give us about 1.6 or 3 over 2. Okay. If you do it in your calculator. Let's do 1.6. So for every carbon with hydrogen, let's keep it simple. Let's do the fractions. Because I don't feel like doing 1.6 times something crazy. And if we use the fractions, it's way easier to look at it this way. So we've got C1, so for every carbon, we've got 3 over 2 hydrogens. So pretty similar to our last one, actually. We have to multiply because we can't have that fraction there. So C1H3 over 2. Okay. A 2 would get me to get rid of that fraction, 3 over 2. So if we go ahead and multiply, C1 times 2, we got C2. And then H3 over 2 times 2 would just be 3. So C2H3 would be our answer for number 10. Okay, remember, keep it simple, guys. Let's not use decimals for these. And we gotta use more complicated numbers. Okay, number 11, mapropylene, I have no idea how to say that. Anyway, has the following mass composition. This is a antidepressant apparently. I don't know why they tell us that. It's kind of weird. And has the following mass composition. Carbon is 86.59%. Hydrogen is 8.35%. And nitrogen is the rest of the what's in there. So, what is the empirical formula of mapropylene? So if you notice here, they actually didn't give us any weights. They didn't give us grams like in the first two. That's because they gave us percentage, and that's the next best thing. So whenever you get a percentage, if you remember, a percentage is out of 100. So whenever you get a percentage, you would assume, just to make it a simpler way, that it's out of 100 grams. Okay, so these percentages, they're going to get treated like grams, like a weight. So 86.59 grams. Grams of carbon. Okay. The next one would be 8.35% of hydrogen. But remember, we're treating it just like a gram. 8.35 grams of hydrogen. Oh man, I'm not gonna have enough space. Okay, and N is the rest of the formula, so we can just kind of figure that out. 86.59 plus 8.35. That gives us 94.94. But remember, we're treating like we're treating this like it's out of 100 grams. So you do 100 minus 94.94. That gives us 5.06. 5.06 grams of nitrogen. Okay, since I'm running out of room, I'm gonna do a little erasing. Hopefully, you guys could just go back on the video. So I'll give myself some room here. And just know that the work for number 11 is going to be on top of it. Okay, there we go. So we got 86.59 grams of carbon, 8.35 grams of hydrogen, and 5.06 grams of nitrogen. So what do we do here? What we do is the same stuff we've been doing. If we start off with 86.59 grams of carbon, 86.59 grams of carbon, we want to turn this into moles, 86.59 grams of carbon. For every mole of carbon over the mass of carbon, which is 12.011, 12.011, can cancel these out, and now we have the moles. So 86.59 divided by 12.011 will give us 7.209 moles of carbon. Okay, there we go. Next, hydrogen, 8.35 grams of hydrogen times, remember, same thing, 1 mole of hydrogen. Oh my god. Over, how much does that hydrogen weigh? 1.008. 1.008 grams of hydrogen. So these grams cancel out. And now we just end up dividing 8.35 divided by 1.008. If you're the type of student that just uses 1, then that's okay too. You should get the same result. Anyway, whatever number you use, 1 or 1.008, you're going to get 8.28. 0.28 moles of hydrogen. Okay, and then the final one we have is nitrogen, 5.06 grams of nitrogen over 1. Nitrogen, I got the weight down here, 14.007. So how much would 1 mole be? 1 mole of nitrogen over 14.007. How much would 1 mole be? Well, 5.06 divided by 14.007 gives us 0.36. 0.36 moles of nitrogen. Okay? And remember, anytime you get empirical formula on your question, you gotta divide by the lower number of moles. So here, obviously, 0.36 moles of N is our lowest one. 0.36, we're going to divide all of these by 0.36. Okay, so we divide 7.29 by 0.36. By 0.36. We end up with 20.02. Okay. 8.28 moles of hydrogen over 0.36. We end up with 23. 23. What? 23.01. Not too much of a difference. And then 0.36 over 0.36, well, that's just 1. Okay, now remember, for empirical formulas, we only use whole numbers. So these decimals, we don't really need them. Right there, so 20, 23, and 1. Our formula for this maprotein would be CHN C20 H23 and N1. Okay, so there we go. Those 3 are empirical formula questions. Really, the only step we added is dividing the lower number of moles for these questions. And remember, we're doing the same thing for limiting reagents or reactants, but we're not there yet. Next video should be limiting reactants.